Review. Okay, so there's not a lot of lessons in this chapter. Some of you, we've only had one test so far, and some of you didn't do very well in that one. So this is kind of going to be your chance to pull that grade back up. All you have to do to get your grade to go higher is to beat your last test grade. That would make your test go higher. Because the test category just averages all your tests together. Now, if you got a good grade on your test, that makes it harder for your grade to stay up. But that's just kind of how it works. All right. So, number one. Let's start with Kenton. I kind of feel like we stopped there the other day. Yeah, uh-oh case. Uh-oh. Kenton, what do you think we should do on number one? Well, what's it mean when the parentheses are right next to each other? Multiply. Does order of multiplication matter?
Yeah.
No. So we can go ahead and do, it's 6 times m cubed times m squared times n to the fifth. So it's just a bunch of stuff multiplied together. So really, you can multiply whatever we want. What's 6 times negative 3? Negative 18. Okay, now here's the important part. What is m to the second times m? Right. The m means there's like m to the 1. There's like one of them. So when you multiply these together, how many m's are we multiplying together? 3. When you multiply the same base, you add their exponents. So this will be m to the third. And then Kenton, I forgot the negative. There. Oh, no, I didn't. Never mind. What is n to the fifth times n to the seventh going to be? Yeah, you add them together, yes. So n to the 12th. Number 3. Okay, so when we're dividing, technically they should have put parentheses around the divided by 980c squared. Because order of operations would screw this one up. But what they meant was like a division bar. 81, A4, B3, C2. Divided by 980c squared. Okay, so Case, what do we do when we're dividing with the exponents? Subtract. So on the normal number, 81 divided by 9 is 9. Now, when I write the 9 there, it's kind of like 9 over 1. Sometimes we don't need a denominator, we don't need a fraction, but just to remind you of that. A to the fourth divided by A.
A to the third.
Right. Invisible 1, so A to the third. And then B to the...
B to just B.
B to the first, B. And then C's, there's not only C squared on top.
No.
Oh, no, I didn't copy it down right, did I? There's C squared on the bottom. Oh, I think I tried to, just didn't draw. C squared divided by C squared.
That would change the B then.
Oh, yeah. Did I copy it right that time? Yeah. Okay. So, yeah, the B is now B squared. So, what about the C's?
It would just cancel out.
No, it's still just B.
What do you...
3 minus 1 is 2.
I think there's only one on the bottom one there. Yeah. Okay, yeah, the C's will cancel out. 2 minus 2, C to the 0, which is 1. C to the 0 equals 1, but 1 times that is just that. It just goes away. Before we move on, I'm sure there's a couple like this. What if I had like b to the third divided by b to the fifth?
B to the negative 2.
3 minus 5 is negative 2, but what did we often do with the negative exponents? Right, we flipped it upside down. So instead of like b to the negative 2 over 1, it's 1 over b squared. They don't tell us we have to do that in the first section.
How would you do number?
Actually, I don't even think they gave us one of those in the first section, so I guess
How would you do
don't have to worry about it. In the 14 through 16, that happens though. So I guess we'll worry about it when we get there.
How would we do number 4?
Well, when you multiply fractions, you do top times top and bottom times bottom, right? And then it just is in one fraction. And then you just, when you divide the top divided by the bottom, it'll be kind of like the one we just did on number 3. So on number 4, the tops just multiply together. So the top will become 4w7z cubed. It just goes together. The bottom will become 2w squared z. Okay, but then you do the top divided by the bottom just like we did on number 3. Or number 5. Brooke, what will number 5 become? 8 divided by 2? M to the 4th divided by m to the 2nd? M2, so she's just subtracting the exponents. N to the 2nd divided by n? Just n, and then p to the 5th divided by p. P to the 4th. Y squared over x negative 3y2. Wait, is that right? Yep. Okay, Owen, what can we do on this one?
Would we just keep x to negative third? Or flip?
Yeah, let's flip that. How about the y's?
The y's would just stay y. We just go to y. 2 minus 2.
2 minus 2, so what happens?
The exponents disappear, so we just do y.
No, okay, 2 minus 2 is 0. Y to the 0
Just y.
is just 1. And 1 times whatever is just whatever. So they kind of just cancel out. So if nothing is left on top, you can put a 1 up there. What can we do with x to the negative 3 on the bottom though?
We can flip.
You can put it on the top as x to the 3rd. You could call this x to the 3rd over 1, but it's just not necessary. Alright, number 9. 2 to the 5th times 2 to the x minus 5. Just the one Miranda wanted to do. Any ideas, Miranda? Yes, that's correct. So when you're multiplying the same base, you add those two. So we're doing 5 plus x minus 5. We don't really need parentheses here, but because we're adding, but just to show it. So how does this simplify? 5 plus x minus 5.
5x minus 5.
No, 5x would mean 5 times x. So if there was no plus right there, it would be like 5x minus 25. But because there's a plus right there, it's basically like that. The parentheses don't really do anything. These two don't add together because they're not like terms. But what's 5 and minus 5 do? Just 0 goes away. So all we have left is x. Now x is the exponent, right? That's what the exponents add up to. So it's just 2 to the x. Number All right. Hmm?
2 times 2 equals 4.
Yes. Okay. So let's say we were doing this in exponential form. 2 to the 1 times 2 to the 1. That should equal 4, right?
Yeah.
So, but that's the same thing as 2 to the second. So the 4 is kind of inside of the exponent. So if you're multiplying this thing, let me do a different example. Let's say it's 2 to the second times 2 to the second. This would equal 2 to the fourth, not 4 to the fourth.
So do we put that out
It's-
there with the X?
It's 4 2's multiplied together. So you don't do this 2 times 2. The 2 times 2 is inside here. So you don't do 2 times 2 and 2 plus 2. That would kind of be like doubling up. You only add the exponents. Most of the problems we did were like x to the second times x to the second, so we didn't have to worry about it. We just added the exponents. But the way you were saying it, you would have made it like 2x to the fourth, and that would have been wrong. Anyway, that does confuse a lot of people, but just add the exponent, leave the base the same. Number 10 is a little bit different. I'm not going to do that one, but what is different about number 10?
Just adding and subtracting.
Yeah, we're adding and subtracting. So what you need to do is simplify all three of those terms. Like the first term, for example, you can put j negative 2 and j to the fifth together, and it just becomes j to the third, like you add the exponents. So the first term is 2j to the third, k to the fourth. When you put those j's together. If any of the terms are like terms after you get done simplifying each term, you add those together, or subtract, I guess, in this case. Okay? Yeah. So simplify each of those three terms. If they're like terms, they can be added together. All right, number 11. Short chapter, kind of challenging though, right? M negative 3, R7, S negative 4. But really, most of what we're doing is adding and subtracting. You just have to know when to add and when to subtract. M, R, S. Okay, the directions on number 11 are leave everything in the numerator. So if we get a negative exponent, we are not going to flip it to the bottom. We're just going to try to put everything on the top. So there will be like no fraction answer or anything. Let's see, where are we at? Moses, what are we going to do with that negative 3?
We're gonna leave it there.
Nothing. Yeah, we're going to do nothing. Okay. What are we going to do with the m's?
We're gonna cancel them out, so it'd be m to the... Oh, we get to...
What do we do when we divide? What do we do with the exponents when we subtract? So it's negative 3 minus 1. Negative 3 minus 1. So it's negative 4. So it's m to the negative fourth. Sometimes they say no positive exponents and we have to move that to the bottom, but in this case they said leave it in the numerator, leave it on top. So we're going to leave that alone. And then the r's.
7 minus 2 is 5.
And the s's.
Negative 4 minus 2 is negative 6.
Yeah, negative 4 minus 2. Now if you still struggle, this is basically left 4, left 2. So it's like left 6 is negative 6. If you still struggle with that, just plug it in your calculator, make sure you get it. So s to the negative 6. Now where are we going to go? Mallory. And we'll do Mallory and then we'll go this way. Except for Wyatt said he wants to go. should I do? Why? Do you guys think? Should we take a vote?
Does that mean I'd have to go next, or?
No, it's just Wyatt.
Oh, just
He's special.
yes, it is.
That's what Leo tells me. Number 13, negative 3x. Oh gosh, I don't want to write all that down. He might not meant it in the same sense though. Negative 3x to the second one. Oh gosh. Mallory, I saved the good one for you. On number 12, let's take a peek at that. There's a couple ways you could do it. I would just, probably the easiest way. So one thing you could do is just put that stuff outside the parentheses over 1 and then try and multiply them together. Another thing you could do is inside the parentheses, that c to the negative third, you could just move to the top as c to the third. So in parentheses you just have a squared, b squared, c to the third. And then it would just be a multiply problem, so you could add all the exponents. Okay, if you get confused, you can ask me later. But all right, lots going on 13. This is definitely the hardest in this section. What should we do first, Mallory? What do you think? Distribute what? Yeah. So exponents come first. Not technically like in parentheses comes first, but can we do anything with that? No. But yeah, we can square this stuff. So everything gets squared, including the negative, by the way. It's like you're taking all of this times itself. Like if I wrote it out, it would look like this. Like we're supposed to multiply all this times itself. So what is a negative squared? Negative times negative is positive. Two negatives multiply. Now, out here there is a third negative. So there's kind of like 2 in parentheses because it's squared. And that cancels out, makes a positive. But there is another negative out here, which will make our final answer negative. Okay, so I'm just going to put a negative out there and then kind of forget about those negatives. I'm not talking about the negatives in the exponent. This means something totally different. These two really don't affect each other at all. Like negatives in the exponents do not affect the negative of the problem. I know that's confusing, but these negatives totally different than those. All right, so what will this y turn into? Y squared. Okay, 2 squared is 4. If it was 3, it would be 3 squared 9, not 6, right? Okay, what do we do with the exponents when we have a power to a power? Multiply. 3 times 2. Okay, that's the parentheses. Done. We could simplify this because it does simplify. Or we could just multiply these two together. Okay, when you multiply fractions, what do? If you do like 3/4 times 1/5, how do we do that? It's just the top times the top and the bottom times the bottom. So you just do this times this, that goes on top, this times this, that goes on the bottom. I probably wouldn't be too so mean as put this on the test, maybe as a bonus. There's just a lot of steps. So back to Mallory. Mallory, what will the top become if I multiply these two together? Okay, not -6, no. So here we multiplied 3 times 2. But here, when we do y times y, we're going to add the exponents. You guys see the difference? A power to another power, that's multiply. But when you do x times x, that's add. So this case would be adding. -3 plus 2, -1. Okay, Mallory, what would the bottom become? 6 minus 1, or 6 plus -1? Just 5. And then there's also a y down there. Okay, is there anything else we can do? Yeah, we can divide those, right? We can simplify. Does -3 over 4 simplify? No. On this section, we're supposed to leave everything in the numerator, like -3/4 instead of like a fraction division bar thing. And then Mallory, how many x's do we have here? Yes. 2 minus 5, that's how many? -3. 2 minus 5. And then on the y's, it's -1 minus 1. -1 minus 1. So it's y to the -2. That was a toughie, wasn't it? Number 12 is a little bit easier. Okay, it's just move that c to the -3 to the top as c to the 3rd. And then since everything is just multiply, you could just add all those exponents. Not as bad. Okay, 15. Alright, where are we at? 15 actually looks a lot like 12. 15 on 14 through 16, the directions change, only positive exponents. So if we get a negative exponent, we're going to have to flip. Josiah, you got your book? Alright. Leah, do you know what we need to do first on 15? Or what's something we could do on 15? Okay, it's a bunch of multiply, right? Like all those things next to each other just means times. So we can just start multiplying stuff. So the first thing we can multiply is what's 5 times -3? So that would just be -15 for the normal numbers. But then when we go to the x's, what's x to the -3 times x to the -3? What should we do? Leah, what should we do with the exponents there if we're doing x to the -3 times x to the -3? Add them. Right. And -3 plus -3, if you guys think about the number line, -3 plus -3, -6 over here. So it's x to the -6. Where am I at? So then we got y2, y. When it just, y2 times y, so when it just says y, that means there's one of them. So 2 plus 1. And then on the z's, we got 4 plus -5. So that's on the number line, it's like 4 plus -5, -1. Okay, on this, unlike the last section, on this section we cannot leave the negative exponents alone. So the negative 15 and the y to the third are not going anywhere. The negative 15, doesn't really matter actually where we put this negative, we could put it in the middle or whatever. Anyways, but the negative, the 15, the y to the third, they don't really need to move. But the x to the negative 6 is going to flip to the bottom as x to the 6. The z to the negative 1 is going to flip to the bottom. Right now, if you wrote this as a fraction, it would just be all over 1, right? So this stuff is going to go to the bottom. So we got z to the 1 on the bottom, which is just z. So that would be it. All right, negative a cubed. All right, Josiah, any ideas what we could do with this one? Negative 2 to the 2. So let's start with this, Josiah. What's negative 2 to the just positive 2? What would that be? Okay, the square just means we multiply it by itself, right? Like negative 2 times negative 2. Yes, so that would be 4. But there's a negative exponent. Now this is the part where we all screw up. What's the negative exponent do? No. Flips it. Okay, this negative means something totally different than this negative. Okay, this negative affects like whether it's a positive or negative, like on the number line. This negative just means whether it's upside down or not. Okay, so instead of 4, it's going to be 1 over 4. Okay, and then Josiah, do you know what we're going to do with these exponents? A to the third to the negative 2. Do you know what we'll do with those exponents? Add, multiply, what? Multiply. So that would be 3 times negative 2 is negative 6. So I could put a to the negative 6, but let's go ahead and move it to the bottom as a to the 6th. And then same thing on the b's, negative 5 times negative 2 is positive 10. So that one is going to stay on top. Now if I have a 1 up here, 1 times b to the 10th, that 1 doesn't really do anything now, so I don't really need it. Alright, but that would be it. By the way, on this number part, you could kind of cheat and use your calculator. If you know how to do it without a calculator, a lot faster. Negative 2 squared is 4, but the negative exponent makes it 1/4. Your calculator might spit out 0.25. I guess that'd be okay. Not my favorite, but okay. 18. I think I'd like to try to get through 25 today. That would make me feel warm and fuzzy. On 18, though, I remember people always asking and being confused. So let's look at it. I'm not going to do it, but I'll help you guys set it up. It says V equals 1/3 pi r squared h. I doubt you guys have seen this before. Doesn't really matter. That is the volume formula for a cone. Doesn't matter. You don't need to know what it does or what it means right now. Oh, they tell you in the problem it's volume of a cone. But they just tell you like what to plug in, and you're supposed to simplify it basically. It says the cone has a radius of AB to the third. So what should we do with that AB to the third, you guys think?
Plug it in for R.
Right. R stands for radius probably, right? So I'm going to replace the R with, AB to the third. Okay, so the R gets replaced. That little 2 exponent is right there now. Okay. Pi is a constant. That value is not going to change. Pi is worth 3 points. That just stays the same. They're probably going to tell us the height also, though. So what is the height?
6b over a.
6b over a. And they just want you to like clean this up a little bit. Okay. I always have trouble with this because there's like 2 or 3 ways to think about these things. Probably okay, what should we do with this exponent right here? What are we going to be doing right there? What are we going to do with these exponents? Multiply. Okay, and then a, this is like 1 times 2. It's just be a squared. Do you guys know what a on the bottom becomes if we put it on the top?
A to
A to the negative 1. Okay, the reason I might want to do that is because if everything's on the top now, and you can just multiply all of those together, which means you can just add the exponents. But before you try to add the exponents, you need to multiply those by 2. Anyway, that's the problem. Okay, number 19, write .000319 in scientific notation. Okay, I think we're at Corbin. What day? I think we do this on Monday, maybe something like that. Corbin, you remember how we did this in scientific notation?
He would move the decimal backwards to 3.19.
Right. You move the decimal after the first non-zero digit, 3.19, then what?
And then you count how many they were, which would be times 10 by 4.
Yeah, so if it's a decimal number though, it actually was a negative 4. Did anybody find the scientific notation button on the calculator? You could plug this back in the calculator and then see if it equals that as a test. 20 standard notation just means change it back to a normal number. The decimal place would just move 8 times to the right because you're multiplying by 10 to the positive 8. The number should get much bigger. Okay, that's 19. 21. 10, 9 times 10 to the 8. Okay, the homework on this lesson wasn't great. I felt like we didn't get as many A's and B's as normal. So if you don't feel confident, what I would just do is plug all this in the calculator. It'll spit out a normal number and then change it back into scientific notation. That's the safest bet. But if you know how to do these right, they're pretty quick. Okay, so on the division, we're just going to do, AJ, what do you think we're going to do here?
We're going to divide.
Okay, so 9 divided by 3,
Is
and then what's 10 to the 8th divided by 10 to the 3rd?
the
Yes. Okay. Make sure your answer is actually still in scientific notation. Is this scientific notation?
Sort of.
Yes, it is. So we don't have to fix it. It's just that's it. Okay. 23. 5 times 10 is 4. All right. So this one's different. It's not division, it's an exponent. So, Bo, do you have any guesses what we're going to do here? Any ideas?
Would you subtract the 3?
No? Okay. Both of these are going to be to the third power. It's kind of like when we do like 2 to the, square to the third. Like you have to take everything in parentheses to the third power. So 5 to the third is 5 times 5 times 5. And 5 times 5 is 25. Times 5 is 125. Okay, 10 to the fourth to the third though. Bo, what do you think we'll do with these exponents here? Nope. If it's a power to a power, what's it normally mean when you have like numbers next to each other in parentheses? Multiply. And that's what it is with these powers too. So this will actually be 10 to the 12. Okay. Is this in scientific notation right now? No. The decimal is right here, right now. It's invisible at the end. Where is it supposed to be?
After the 1.
After the 1. So it's 1.25. Now, when I move the decimal, I change the value, so I have to kind of make up for it. When I moved the decimal to the left 2 spaces, did I make the number smaller or bigger? I made it smaller. It went from 125 to 1.25. So to make up for it, I have to make this 2 steps bigger. So 12 becomes 14. Again, that's kind of confusing. So if you get confused, just plug that in your calculator, just as it's written. It'll give you a big number, and then you're going to have to change that into scientific notation.
So if the decimal goes to the left, it adds exponents when it goes to the
Yeah,
right.
so the way I think about it, instead of thinking it left and right, this number, I made 125 into 1.25. So I made it a lot smaller.
Yeah.
By 2 moves. So to make up for it, I made the exponent bigger by 2. All right, 25. Yeah, 24 and 25 are the hardest because adding and subtracting. Okay, 25. 4 times 10 to the negative third. Plus 5 times 10 to the negative second. Actually, on 23, that answer might be so big that your calculator would automatically put it in scientific notation, boys. So, yeah, because 10 to the 14th means like 14 digits. So that's probably too big for the calculator, so your calculator might automatically spit out a scientific notation. Okay, this one, however, is not that big. Okay, the way we did adding and subtracting, you can only add and subtract like terms. 10 to the negative third and 10 to the negative second are not like terms. I could turn this, well, usually you want to do this one. Kind of doesn't matter, but I could turn this into 10 to the negative 2. If I make this one bigger, I need to make this one move smaller. So it's like 0.4 times 10 to the negative 2. Anyway, that's how you would do it without a calculator. Once you have the same 10 to the negative 2, you can just go ahead and add these things. 0.4 plus 5 is 5.4 times 10 to the negative 2. Yeah, those last two are hard. But if you really want to add them together, the powers on the tens have to be the same. They have to be like terms. Those two things. Okay. That's over halfway, I think.